For most of human history, our understanding of the cosmos was limited by what we could see from the ground, blurred by atmosphere, scattered by clouds, dimmed by the light of our own cities. Then came a telescope that left Earth behind. Launched in 1990 aboard the Space Shuttle Discovery, the Hubble Space Telescope became humanity's first permanent eye in space. Orbiting 547 kilometers above the planet, beyond atmospheric distortion, it opened a new window to the universe. But Hubble was more than just a machine. It was, and still is, a voyager of time, a chronicler of the cosmos. It looked back billions of years. It saw galaxies being born, stars dying, black holes spinning, and light stretched by the expansion of space itself. For 35 years, it has transformed astronomy, humbled philosophy, and deepened our connection to the universe. This is the story of Hubble's most extraordinary discoveries, a legacy not just of science, but of vision. It wasn't supposed to happen this way. In April 1990, anticipation was high. Decades of development had culminated in Hubble, a $1.5 billion marvel, capable of peering farther than any telescope before it. But soon after launch, something was wrong. Images were blurry, out of focus. The telescope's primary mirror, machined with stunning precision, was flawed by just 2.2 microns, thinner than a human hair. That small error rendered Hubble's vision far less effective. Public confidence wavered. Critics called it a billion-dollar mistake. But NASA acted. In 1993, astronauts aboard the Shuttle Endeavour performed one of the most complex space missions ever attempted, installing corrective optics, essentially glasses for Hubble. When Hubble opened its corrected eyes, the universe sharpened into breathtaking clarity. In 1995, Hubble aimed its camera at a star-forming region in the Eagle Nebula and captured an image that would become iconic. The pillars of creation, towering columns of gas and dust, where stars are born, appeared like cathedral spires in space. The photo wasn't just visually stunning. It was scientifically profound. It revealed the raw mechanics of stellar birth, ultraviolet light from young stars eroding the gas clouds that birthed them. It captured cosmic evolution in motion, not over hours or years, but millennia. To millions on Earth, it was a spiritual image, a symbol, proof that science could offer not just answers, but awe. What if you stared into a patch of sky so small, it looked completely empty? What would you see? In 1995, astronomers pointed Hubble at a dark sliver of sky near the Big Dipper, an area the size of a grain of sand held at arm's length. Over 10 days, it collected faint light. The result, the Hubble Deep Field. Not emptiness, but thousands of galaxies, each containing billions of stars, some over 10 billion light-years away. Later, the ultra-deep field and extreme deep field pushed even farther, revealing galaxies born when the universe was just 500 million years old. These were not just photographs. They were time machines. Each photon Hubble captured had traveled across cosmic history to reach its mirror. It confirmed the scale of the universe, not merely vast, but functionally infinite. Hubble didn't just look far. It looked deep into the structure of space-time itself. One of its most critical missions was to measure the rate of the universe's expansion, the Hubble constant. Using standard candles like Cepheid variables and Type I supernovae, Hubble refined this measurement to unprecedented precision. But something didn't add up. Distant supernovae appeared fainter than expected. The universe wasn't just expanding, it was accelerating. This shocking result led to the proposal of a new force, dark energy, a mysterious pressure pushing galaxies apart faster and faster. Hubble provided the first solid observational evidence, and with it, cosmology itself was rewritten. We now know only 5% of the universe is made of matter like us. The rest? Dark matter and dark energy, forces and substances we don't yet understand, but which shape everything. At the centers of galaxies, something massive stirs. Invisible, irresistible. Hubble's sensitive spectrographs revealed that supermassive black holes, with millions or billions of solar masses, lurk in the cores of nearly every large galaxy. By measuring how stars orbit these invisible centers, Hubble confirmed their mass, their dominance, their hunger. It peered into active galactic nuclei, blazars, quasars, where jets of matter explode from black holes spinning near light speed. In our own Milky Way, Hubble contributed to tracking stars orbiting a central black hole, Sagittarius A*, silent but immense. These discoveries confirm that black holes aren't rare. They're fundamental, gravitational architects of galaxies. Though not designed for exoplanets, Hubble helped pioneer the study of alien worlds. By watching stars as planets passed in front of them, Hubble analyzed the starlight filtered through exoplanet atmospheres, detecting water vapor, sodium, and even hints of organic molecules. It helped discover HD 209458b, the first exoplanet with an atmosphere observed directly. It found clouds on distant worlds, detected blue skies on some, haze on others. These were no longer invisible points in the dark. They became worlds, dynamic, complex, real. In doing so, Hubble didn't just add data. It made exoplanets visible and made the idea of life beyond Earth feel far more plausible. Galaxies, once thought to be static islands, are in constant interaction. Hubble showed us collisions in progress, galaxies merging, stars ripped apart, gravitational tides reshaping spiral arms. It revealed the antennae galaxies, locked in a slow, elegant dance of destruction and rebirth. It watched clusters collide, generating dark matter maps through gravitational lensing. And it found evidence that our own galaxy is on a collision course with the Andromeda Galaxy, a slow-motion crash set for 4 billion years from now. Through these images, Hubble made clear the cosmos is not peaceful. It is in flux, in motion, in endless transformation. Hubble helped answer deeper questions, too. What is the overall shape of the universe? What is its color? Its fate? Through measurements of cosmic background radiation and galactic redshifts, we now believe the universe is flat, geometrically balanced on the edge between open and closed. And its average color, when all the light is blended together, is a pale beige. Astronomers jokingly dubbed it cosmic latte. It's a poetic truth. The universe, in its entirety, has a color, a character, a presence. Hubble's power wasn't just scientific. It was emotional, cultural, artistic. Its images graced textbooks, museums, screensavers, t-shirts, album covers. It became an icon, a shared window into the cosmos. Astronauts serviced it 5 times. Each mission extended its life, added new instruments, expanded its capabilities. Its impact spans disciplines: physics, astronomy, art, philosophy. It democratized the universe. For the first time, humanity saw the cosmos not as speculation, but as high-resolution truth. Hubble's story is not just a list of discoveries. It's a legacy of light, ancient, delicate, patient. It reminded us that we are part of something vast, that we come from stars, that we are capable of reaching beyond our atmosphere, our history, our limits. And though newer telescopes have joined, James Webb, Euclid, and others, Hubble remains a sentinel, still orbiting, still watching, still capturing photons from billions of years ago. For 35 years, it has peered across time, and its light, and the light it gathered, will never truly fade. Because as long as we look up and wonder, Hubble will always be part of our story.